each of these steps in the Code of Copper project, like doing the regex, doing the parser, doing the refactor of the parser, I felt like each time I was learning something and
Yeah.
taking like what I learned into the next step.
Okay, hello everyone. I'm Gears.
And I'm Moxvallix, and welcome to the Datapack podcast, episode 7.
Episode 7. Okay, so today we're going to continue what we were talking about last episode. So if you haven't seen that, you probably should. We were talking about the Code of Copper Datapack, which was really the first proper project we worked on together. And then it sort of, spanned out into all these different things we're doing now. But last time we sort of talked about what we did in the initial week of the project because it was made for a jam, so the time was sort of limited, so we had to just make something work in a week. And then yeah, we were just talking about the features we did and the way we approached it and everything. But now I think we can go like through the later history of the pack because it's been in development. Well, we haven't touched it in a while now, but it's been in development for over a year, and yeah, we've made quite a lot of changes. So I thought we could just, go through the change log. I've got the change log of all the versions open here, so we can just go through, talk about the different features and changes we made, what we think about them, looking back, see if we remember anything from the development process of that, stuff like that. How does that sound?
Yeah, sounds good.
Yeah, do you want me to go through the thing? So yeah, keep in mind that these are all changes over a year as opposed to, the previous features which we talked about, which were pretty much all within a single week. So it looks like the day after we released Code of Copper, we were back. We released version 0.1.1 the next day, which basically just fixed all the bugs we found just after submitting it. So we had oh yeah, I remember we talked about this last time, the print command not working inside a while loop. So if you looped continuously and printed out something, it would like completely break the formatting and weird stuff would happen.
Yep.
Um there was some weird bug where if you have an if statement in a while loop, it would just break out of it. I have no idea how that happened. Um, Honestly, I don't really remember the full system of how the old interpreter worked, but apparently it did that. So, and also something to do with the placing of blocks, as always. I swear, like every single. We also mentioned this last time, but every single um, every single update we had to fix place. I feel like
Yeah.
every time we go back, we're like, okay, let's check everything's still working, still working, still working. Okay, one of them's failing. Which one is it? Place. Of course, it's place. It's
Yeah.
always been place.
It's always place. Move did have its moments though. Move sure did have its moments.
Who's had yeah. For the most part, it's the ones that actually the ones that aren't
Interact.
part of the Golem standard, as it were, which we'll get into what that is later. But the ones that essentially interact with the world and do something with
Yeah.
the minecart, the chest minecart. Yeah, they just you know,
Have a
they
tendency
don't
to
they
break.
don't yeah, they break much more often than the other ones, which are just sort of computational. Um, yeah, so we got working on that. Oh, we then released another version the same day. We released two versions on the same day, apparently.
What changed
Uh,
in 0.1.2? I don't remember.
well, we added an example program for string addition, apparently, because we didn't have that before.
Oh.
And then, all right, we added pretty printing for, yeah, because I remember in the first version, I think we only pretty printed strings, just so we could have like a nice hello world working, but we didn't have time. I remember implementing the print function like properly. Because before, what we were originally doing while it was in development is we essentially just printed out the internal storage data structure. But obviously, you got to have a working, nice hello world for your initial release of your programming language. So quickly, at the very last minute, I remember I had to implement the the nice
Mm.
formatted printing, but I didn't have time to do it for the full for every data structure. It was basically just for strings, and then everything else still printed out in the old way. But then I guess in 0.1.2, I went through and I basically wrote a function which like recursively traverses the tree. So if it's arrayn, it will iterate through all the elements, and then an object will iterate through all the keys and values. Although I'm not sure we actually had objects at that point, but if statement, oh yeah, if statements removed the following instruction for some reason. I don't know why. They were just like, you run an if statement and then you print something directly after it. The print statement just like doesn't work. There are some weird, like, I don't know how we managed to arrive at that piece of functionality. Like, that's some weird behavior.
Yeah. I specifically remember. Okay, it's a little bit. I'm gonna go on a tangent here. Particularly about the parser around this time. Um,
Yeah,
and one of the biggest issues I had with the parser was recursions within the core loop of the parser. So
yeah.
it could very easily get stuck. Uh, Basically doing a loop and then state would get broken somehow, and it would kind of I don't remember the exact specifics, but it would do weird things because of like
I think, yeah.
because like and it had all of these weird checks it had to do to exit out of these loops. And it ended up just being an absolute nightmare. Um
I think, I seem to remember some cases, which this happened a good number of times, where the parser or the interpreter would start looping infinitely, and it would essentially continuously add data to the storage, and so it would just add so much that it would just like, I mean, the tick rate would slow down to like, it would grind to a halt because we had also, because the parser is so command intensive, we
mm,
had uh we upped the command limit, right? So that you can parse more in one go. Um, the problem with that, of course, is that uh, the problem with that, of course, is that then when you run into an infinite loop, it loops. It runs way more commands in a row, and yeah, not good stuff happens basically. Um, and yeah, it would just like, the tick rate would slow down dramatically, and the whole world would just like stop working basically,
mm,
and the storage was just getting continuously filled with more and more data.
yeah. Oh, yep. There's a
So
lot of times in
that was fun.
and I mean it mainly happens in development now. There's a lot of times where there'll be code of copper will get stuck in a loop and you know about it because the game just like as you mentioned, the game just crawls to a halt. And
Yeah,
it's like
you open the TPS graph in the F3 screen, and it just like, you can literally count the ticks as they go by.
yeah.
It's literally like uh, uh. It's, yeah.
Yeah.
And then you normally got to delete all your storage after that, otherwise it doesn't like it.
Yeah. Um
Anyway, yeah, that happens less now because of the way we've written it.
yeah.
Um,
I
especially
I'm
because we don't have actual recursion anymore. We just have,
yeah.
well,
I'm very
mostly.
excited to I don't think it's the right time yet. I'm very excited to talk about when we get to the parser rewrite for 0.3. Um,
Yeah, I'm actually interested for that because you very much understand how the interpreter works now because you were we wrote that together, right?
yeah,
Um yeah, we wrote the interpreter code together, and as we said last time, that's sort of when we started doing our pair programming thing. So that you would um know the ins and outs of the interpreter, but
mm,
you rewrote the parser before I did that.
yeah,
Before we did that, so I still don't fully understand how the parser works, despite having to go into the code and patch some changes into it occasionally,
yeah.
guided very much by you when we were doing
Um,
that.
well, should I
Yeah.
segue onto that now, or should
I think let's because we've still got a couple of releases to go before that.
yeah, yeah,
Before
yeah.
then,
Okay,
I think let's we'll leave it there. And we'll come back to that in a few minutes.
yeah,
Yeah, so I'm sure there were tons of just weird bugs that got fixed, especially in the like zero point 0.1 versions. A lot of bugs that sort of slowly got patched out from the first release due to weird implementations. Right, so 0.1.3, this one has quite a lot of things. So, oh yeah, we added, um, oh, this still, because a somewhat running joke at the moment, a sort of internal joke that we have is um, that Moxlib, which is this library that you wrote a while back, and we use it very much in Code of Copper and various other of our data packs. For a while now, you've been wanting to rewrite it a lot and release a 0.6.0, but the game keeps getting updated and we never get round to properly rewriting the data pack, and so we basically um, we got to just keep updating the old version to the new game version. So update to 1.20.5, add all the component stuff, update to 1.21, and so what we on version 0.5.13 now or
I
something?
think so. Yeah, it was meant
But
to be rewritten at around 0.5.6, so it's had a lot of
yeah,
updates. That's true.
version 0.1.0 of Code of Copper only required version 0.5.2, and
It's
yeah,
never moved
so
on from 0.5.
yeah. Um, but yeah, so oh yeah, so we added parameters as we called it, which is basically indexing of an array, um, which before we didn't have. So even though we had the dollar inventory variable, it was basically useless because arrays were completely immutable and inaccessible data structures. Um, I guess you could like compare it to an entire other array, but like, I don't know. It was mostly just there for like, I guess it was just
Functional
there to
intent.
say for the ability to access your inventory. But I sort of knew that then until we added indexing, it wouldn't be very helpful.
Yeah.
But we finally did that, which was 3 days after. So these all releases were very quickly released after the initial thing because I guess we still had that initial burst of energy and motivation to work on it. And we just added new things in all the time. So
Yeah. I mean, at this point, I
we're
think
pro-
we were adding things before we even knew the jam results. I think, like, it wasn't
yeah, that's
even
true.
the
This was
results
this
that jam
was
keep us going. That was just, like, pure motivation. Because we're
yeah,
like,
this was before the jam results came out exactly.
yeah.
Um, Also, I remember, yeah, you needed to all variable names were prefixed with a dollar sign to make it easier to parse.
Yes.
You could also, if you wanted to have special characters, you could wrap it in brackets, I think, and then you could do like special characters in the thing. And also, again, due to limitations of the parser, when you were doing array indexing, you needed the brackets.
Right.
So yeah, you couldn't just do dollar array at 0. You would have to do dollar brackets array close brackets and then the square brackets 0.
God, that is horrid.
Um,
That is horrid.
yeah,
Yeah,
yeah.
that's just the array. Like this was the thing of like the interpreter and the parser being so separate at the time, is that like the interpreter could add something, but maybe then like the parser hasn't really taken into consideration this thing, and so
Yeah,
it's like there's a janky workaround to get it working with the parser. That was a very common theme, I guess, in the early days of Code of Copper.
yeah, I definitely think so. Yeah, because we would come up with a feature. I'm like, yep, okay, you go do that, I'll go do that, and then we just like we wouldn't. Because now what we'd probably do is we'd go and look at it, and if it sort of clashed against our current model of the parser and interpreter, um, we might rethink the feature and figure out how it works. But since they were sort of very separate, there wasn't much communication and like yeah. So
Mm.
anyway, oh yeah, we added dev mode, which is now removed, I believe, because we never added it back in. But I definitely found that useful at certain points. It was just for the interpreter. You didn't do it for the parser, but there would basically be a setting where you could enable dev mode, and it would essentially do like a debug print of everything it was doing. Um, so it would say, okay, now we're adding together 1 and 2, and now we're printing out the result 3, and then stuff like that, which I found very helpful. And
Mm.
maybe I should add it at some point. But I'm also aware that dev mode does add extra commands in,
Yeah.
even though they're not actually running anything. They're still doing the check, and that's probably not great. So I'm on the fence about it. You know what would be cool, right? We talked about Zoglin a bit in our Harlequins thing,
Mm.
um, and I'm still on the fence as to whether we should try and write Code of Copper in Zoglin. I feel like we shouldn't um, because the point of it is sort of testing the capabilities of vanilla data packs, and we really want to keep it, I think, in that spirit, sort of.
Yeah. It's kind of like
So
there's a bit of clout
yeah,
to the fact that this was written entirely like
entirely vanilla. Yeah,
yeah. Because like, there's always that feeling when you like see, oh wow, they did an awesome thing like in the thing, and it's like, oh well, they kind of wrote a program that wrote it for them, and it always feels
yeah,
like,
yeah,
I mean, it's still impressive they got it working, and like there's still a lot of work obviously went into writing that program, but it's like it's
yeah. It's
less
it's not quite the same.
it's less personal, I think. Um,
Yeah, it's like if somebody wrote uh, a programming language in assembly, in raw assembly from hand, you'd be much more impressed than if they wrote it in C and then compiled it to assembly, right? That's
yeah,
because, that's, uh, it's a different thing, right? So, but I'm just thinking, if we did write it in Zoglin, we could have a feature which we've already discussed and I think is planned for a future feature of Zoglin, and that is sort of like a building in dev mode. So
mm,
what we would have is we would have like a Zoglin build, like a dev flag, and then that would build in all the dev mode commands, and then when we release it, it just essentially compiles it without all those commands, and that
yeah,
would basically give us the best of both worlds, right? You get the nice development experience, but then you don't get the overhead of commands when you actually release the pack. Um,
yeah, that would be perfect.
but yeah,
Like debug
uh,
symbols, effectively.
yeah, exactly. Um,
Um, yeah,
which is definitely something. This is a really good example of when you would want to use something like that.
oh yeah,
So I think we'll definitely add that to Zoglin.
yeah. And the reason why debug mode never made it into the uh, parser is because the parser is just so like I basically made the decision for the parser to run in one tick,
Yeah.
because I wanted it like you right click on the book and immediately you can run the program, right? That's the goal with that.
Yeah,
And
and
it's
I
expected that
think
the
that's fine
program, yeah, it's expected that the
because like
program
it's the
can,
one-time thing, right? So
yeah,
it causes a little bit of lag maybe, but like it's just once and then but the interpreter has to be like as efficient as possible and like spread itself over multiple ticks so as
yeah.
not to cause persistent lag.
So like it's funny because the two sides optimized for different like metrics. The
Yeah.
parser optimized for least amount of lines of code possible. So
Yeah.
it did some more performance intensive things to hopefully fit within the command limit for like as big of a program that you would want to pass as possible.
Yeah,
Um,
because I remember like with the default command limit, I remember like during the initial development of Coda Copper, you told me like, yeah, I've upped the command limit because um this this is just too it just like you get past one page of code and then it just hits the command limit.
yeah,
Um
and I mean, thankfully
yeah.
we can change the command limit. Like that's it's great that
Yeah,
we can do
that's
that.
it is
Uh,
good.
because I feel like the parser. Ooh, I don't know if the parser's actually. I feel like I optimized the parser a bunch, but then there's so many more features. I'm not sure if it's actually less command intensive now. Because of the nature of the parser being inside of loops, that there's so many different loops that it goes in. Uh, a
Yeah.
single command could add like 50 to 100 to even like 200 to your total commands. That's like,
Yeah, which
uh,
is yeah.
and like where the
The pause is very recursive by nature, so
mm, where the interpreter maybe runs like maybe upwards of 5,000 commands per tick. Um, and at the time, I think it was even like uh, we had it. I think run every 2 ticks or something. It was like
yeah,
quite
it was. I think it was running every 2 ticks to prevent the thing of with the Moxlib stringify thing, maybe.
I
Or
think as well
no,
because
no, it
you
wasn't
split
that.
it into two
It
sides.
was
It had
right.
an
Okay, so that was later. That was later.
oh that was later. Okay.
Where is? Hang on. Let me. Okay, it's not listed on the change log, but later on to try and optimize the interpreter a bit and make it less laggy, I split it up into 2 phases where it would alternate between ticks. So the first one was the decode phase, which is, and this was sort of based on how actual CPUs work. This is more or less how CPUs work, right? They do um, they do in phases. So the first phase is decode, where it takes the AST and it sort of goes through and resolves a lot of um the expressions and stuff, and then execute where it basically takes the thing from the previous stick and actually runs the logic of it.
Yeah.
And we'll get into that in a bit because that was one of the main problems uh with adding functions and why it was so tricky. Um, Later when we want to do that. Anyway, yeah, but so yeah, the interpreter was is definitely they're two different pieces of code and they're treated differently. So yeah, you gotta reason about them differently essentially, and so that's why they one got dev mode and the other didn't, and also just because I decided to add that and I added it to the interpreter because I wanted that and I found it useful and you didn't need that, and there you go. We were working on them separately, so
Yeah.
yeah. Well, there are a lot of bug fixes uh, in that version, um, but I won't go through. I won't go through them because most of them seem just like minor little ones. Okay, should we go to 0.1.4, I guess?
Yep.
So this is when you first refactor the parser.
Oh, this is for
Um,
refactor one. Okay. Yeah.
that's the initial refactor.
Right.
Um, and so yeah. Oh yeah, so then you removed the need for brackets with variables within arrays. Does that mean within arrays or means ones that are indexed? I don't know, but
I think no. I think to write a variable inside an array, you had to use brackets, like inline in the array.
right, yeah.
Yeah.
Yeah, there was some like sort of weird quirks with the parser that you had to do certain syntax in certain places because it made it easier to parse. Um, but yeah, so I think a lot of those sort of weird janky stuff, operators no longer need space between them literals. Oh yeah, because you couldn't do 1 plus 1 all next to each other. You had to do 1 space plus space 1.
Yeah.
Um,
All of these things
which
were
is
just because so much quicker to implement, and
yeah. It's just you do it in like the way that works but isn't very versatile at
yeah,
the time, uh and then you go back and fix it later.
yeah.
Um
And so this first refactor, the code was very much cleaned up, and it was very like a lot of bugs were fixed, but it didn't change the fundamentals of how the parser worked. So there were still
yeah.
some issues the parser had, like some fundamental flaws in the parser, and like partly due to time constraints, partly due to I've never written a parser before. This is like the first thing I ever, like the first parser I ever really wrote. Um,
Yeah. And
so
it's definitely different from a parser you'd write in another programming language because um yeah, it's MC function, so certain sort of constructs or programming paradigms which work well in other languages don't really apply to MC functions. So you got to think about it in a bit of a different way.
yeah,
Um, yeah, and then also yeah, it just says lots of behind the scenes improvements. So yeah, you just sort of rewrote bits and improved certain bits. Uh, yep, and then. Okay, that was basically that. The main change was the refactor of the parser. I'm not sure there was any interpreter change, except maybe a couple bug fixes
yeah,
in that version. Okay, so 0.2 is where we started to. Obviously, it's a major release, or well, no, it's a minor release, but since we were still in what do
it's
you call it? In like
yeah,
the zero era.
yeah. The semantic
It's
versioning before major version one, you're in this pre-release phase, and basically the minor version becomes your major version effectively, according to
yeah.
the semantic versioning spec, which we use. Most projects nowadays use it. Um,
Yeah, I love. I didn't know about semantic versioning until, I mean, fairly recently, a couple years ago, maybe. But yeah, it's a great versioning system.
yeah,
Um, yeah. So yeah, so 0.2.0, we made some breaking changes because we're like, okay, we've done about as much as we can, improving the existing thing, fixing all the bugs that were in the initial thing, cleaning up the code and everything. Um, now it's time to make real changes. Um, sorry, I'm trying to really. No, why is what's he doing? What's he doing? What the heck?
those that
Sorry.
can't see,
I
we're rolling. Well, we're getting villagers ready right now, and they are being a pain as expected.
where the hell did he go? Okay. Anyway, I'll do that in a second. Right. So 0.2. Yeah, we started cleaning up the syntax. Yeah. So I think here is where we need. Yeah. Here we remove the need for the dollar sign at the beginning of a variable name.
Nice.
Got there before PHP did.
Yippee!
Um, which Anyway, so yeah, I guess yeah, you redid the parser so that now if it essentially finds an expression which just starts with a character, like a letter character, then it starts an alphanumeric.
Yep.
Um, we added we added regex. So yeah, at this
Oh, right.
point,
Yes.
because right, we talked about in the previous version having uh the initial inspiration for Code of Copper, or the initial reason we started working on the jam was because we decided to make a regular expression data pack. But obviously that got postponed because the jam. Um, but then, um, but then we did actually go back and implement regular expressions afterwards. Um, and yeah, so once we did that, we added it to the programming language. So we added regular expressions. We made it into a library, so it's not just like a data pack which does that. We made it a whole library, so any data pack can use it. And then we implemented it in Code of Copper.
Yeah.
What is this guy's problem? Why does he keep going into this? Anyway,
Yeah. So,
oh, yeah,
actually, can I talk on the regex for a little bit?
yeah, yeah,
Um,
yeah.
we
Go ahead.
decided because I'd done the parser for Code of Copper and Gears had done the interpreter, we decided that we should switch roles doing the regex so that Gears would parse the regex syntax and I would then perform the regex matching. So I'd do the quote unquote interpreting of the regex. Um, and I think that might be the hardest piece of code I've ever had to implement in just anything. Um,
That's saying something.
that's saying something. I like as a professional coder who programs as a day job. The hardest piece of code I ever written was a regex matcher in MC function, and
Yeah, I mean, MC function. I will say MC function was never really made to match regex.
no, no, it was not.
That's not the initial design
Yeah. So
purpose of the language.
yeah, so I was stuck. I think it took me about a week. It took me about a week before I started even implementing it after we had like started working on the project. And that was
Yeah.
just me researching on how to make it work.
Mm-hmm.
And I found, I think it was Ken Thompson's paper on like his regex implementation or like
Oh
some like
yeah,
I read
nice.
a bunch of regex implementation papers um, to varying levels of success, and I did eventually get it working somewhat. It still has some bugs. There's some
It still
issues it
has some bugs,
has.
and we haven't touched it in so damn long
We haven't touched it, but
because it's
surprisingly, it hasn't broken in all of the updates. Really, like
yeah, that's true.
the only thing that broke obviously is we had to rename some of the folders for 1.21.
Yeah.
Um, but it's
But yeah,
remained fairly
we
stable.
really should go back to it at some point and
Yeah.
fix it up again. But like, um, every time we do, it's like, I don't understand the code. You don't understand the code. None of
Oh,
us
I
understand the code.
barely remember how it works, so yeah, it'll be tricky. We would have to do a lot of reading through of what it is. But yeah, it was super fun to implement though. Very challenging.
Yeah.
Um, but it was a good learning experience, and I think like each of these steps in the Code of Copper like project, like doing the regex, doing the parser, doing the refactor of the parser, I felt like each time I was learning something and
Yeah.
taking like what I learned into the next step. And
Mhm.
when we get around to 0.3 discussion and I talk about the parser rewrite, I really want to focus on like all of the elements I learned going into that parser and then the interpreter rewrite. Right? That I feel like there's a
Yep.
very clear um like set of steps of me learning more about technical Minecraft, more about even computer science, like just working on Code of Copper. Um,
Yeah, it definitely helped to sort of think about certain things in a different way, or um, approach problems differently depending on the situation, because it really is sort of a unique project to work on, right? Because MC Function isn't like any other programming language that exists,
yeah,
and there's some sort of weird workarounds in there.
yeah, yeah,
Um,
yeah.
I just remembered something from seeing this changelog. In the initial version of Code of Copper, um, for the let instruction, you had to use a string for the variable name. Like in quotes, you had to do let quote variable name close quote.
Oh, that is, oh, that is terrible.
And then luckily in 0.2 we we removed that, and obviously we had to wait until 0.2 to do that because it's a breaking change, but we removed the need for that, and it's now just a regular old alphanumeric, and it's stuck that way um for the rest of eternity, because obviously alphanumerics are way superior to string literals for variable names.
Yeah,
Um,
yeah,
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 we
yeah.
fixed another bug with place, of course.
Of
Two
course,
actually. I
always.
remember one. I remember one of these, which was that basically we were using an item modifier to remove one durability from the tools whenever uh whenever the golem used a tool with the place command.
Yeah.
But item modifiers don't do the checks that regular using of tools does, and so the tool would just go into negative durability, which was kind of funny and pretty cursed. Uh, but yeah, it would just go infinitely into a negative durability until the player used it, and then it would actually break.
Or
Um,
until it wraps around again.
that would take a very long time.
I remember that one. That was fun.
I remember I actually discovered that on myself because I'd started playing through the data pack at that point. I played it in a survival world of mine, and I
Yeah.
and I was create a little cobblestone generator with a golem with a pickaxe that would automatically break it, and then I came back to check on it after a while. I was like, oh, hang on a second, this isn't supposed to happen. Uh, yeah.
Yeah.
But we fixed that. And then, well, we made a lot of changes. Yeah, 0.2.1, we added string and regex escaping. So before you couldn't use quotes inside a string literal. That was just impossible. But then we added to the parser, or you added to the parser.
Yep.
If you find a backslash, it will escape the next thing.
Mm-hmm.
Um, And I remember at that point we used like a custom, or not a custom, but like a special Unicode character um, to put in the print command for when we were printing out strings, so break we didn't break the tellraw command because we were using like interpret true, and that would just like break it. I think
Yeah.
that's now gone. We now just use single quotes, I believe. Um,
Yeah, we had like it
that
was a
was a thing.
weird double quote Unicode character. Oh, and speaking
Yeah.
about weird characters, I wanna bring up another side tangent. Um, a new line, basically working with
Oh
new
yeah.
lines in so for people that don't know, new line is a character, so like any other character like space, letters, numbers. There's a new line character which does the line break in most programs, right? Working with those in MC function is a pain because you can't write them into data storage. The only way you can get them into data storage is via a loot table,
Is using a loot
and
table.
then
Yeah.
setting the loot table on an entity, and then grabbing the data from that, which
There's
is
an
a
entire
roundabout way.
Moxlib storage dedicated to holding the new line character.
Yep, it's such an important character for string parsing, and it's such a pain to work with. So where I'm getting to here is the parser actually, as soon as it sees a new line right at the start, it swaps it out for a string containing the caret. So it's caret n to mean new line. And so the
Yep.
parser, everywhere in the parser, uses this caret n to represent new lines. So if you ever print a string with a new line in it, it will. I don't know how you get a string with a new line in Code of Copper, but if you do manage to do that, I don't.
You can put a new line because unlike a lot
Oh,
of
does it?
programming languages um where you literally where strings can only be single line,
Yeah.
Code of Copper allows multi-line strings,
Oh,
and
right.
so you can just literally put a new line there. But yes, it does. I can confirm I have tested it before. If you print, we may have fixed it at this point, but if you print out a string with a line break in it, it does actually print caret n instead
Yeah.
of a new line.
So that's just
Uh,
a fun little quirk of the parser, and that still exists. Like that was the solution, I think, right from the start. That part has never changed about the
yeah.
parser. Is there's this caret n character, and there's a couple others.
There's
There's
also
caret
caret,
x
yeah,
for
x for
end
the
of
end. Is
file.
that caret w? I feel like.
Caret w is what is caret w used for? Caret w I think is a special character for use in the um, keyword lookup table. It
Yeah, yeah, yeah.
basically matches against any white space character.
Oh right, yeah, yeah, yeah. Yeah, it's
But
white
that
space.
one should never be seen. Like that one should never show up because that's like only an
No.
internal flag. It doesn't
Yeah.
actually get put in the text. Whereas caret x, you will see that in error messages sometimes. Meaning basically if you didn't close a string, it will say invalid character caret x.
Yeah. We should
Except
go
it
through and
closes.
improve the error messages at some point because some of them are a
Yeah.
little hard to follow.
The
Um,
parser's error messages. I wrote them in the style of Ruby error messages, which are famously hard to understand sometimes. So it has a lot of unexpected blah, expected blah, and I feel like it's
yeah.
possibly not that intuitive.
Yeah, I generally prefer messages expected thing found other thing.
Yeah,
Um,
yeah,
but yeah, also locations would be really nice because sometimes it's really hard to figure out where the error is.
yeah. And
Um,
the funny thing is that the parser has the concept of a line, and it's built into the parser.
yeah,
It's never used. It's never used anywhere, even though lines are built in, and I think it even increments a line number. Um, but yeah, it doesn't store obviously character number, and the lines are
I mean, line number
forgotten.
would be enough really, but
Yeah, it's basically optimally we'll go back to the parser at some point together and clean it up.
yeah.
Um, okay, so how much more of 0.2 do we have to go through?
Two more releases and then we can get on to the to 0.3.
All right, all right.
Um, oh, and it was also here where where we added all the new interaction system, whereas before we were just detecting right click to start the program was just literally opening the Golem's inventory, which for obvious reasons is a little bit annoying. But we added the whole interaction entity around it and stuff like that.
Yeah.
So
Well, it was perfect because the interaction entities came out like this is just another case of everything coming up Coda Copper. The interaction entities were just came out at the perfect time for us to be able to do that. Like
yeah,
pretty much as soon as they announced the
Absolutely.
interaction entities, we updated the bot to use them, and also the display entity for the right, because it used to use an armor stand, and there were actually
Yeah.
that was a bug. There was a bug in a really early version that you could take the bot off of the armor stand. Um,
Yeah, yeah, yeah. I saw that in the fixes, but I didn't mention it because we're trying to go through them quickly.
yeah,
How long have we been going for actually? Because I feel like we've been
we're at
talking for ages
46
already.
minutes now.
Okay,
So this is
well,
going to be a long episode because we still have
yeah, we still
0.3
got the
to go
whole.
through, which is
Okay, well, let's gloss quickly over the next two releases, I guess.
yeah, yeah,
Um, so 0.2.2 is where we added the oxidization and progression system. So
right,
initially the example programs could just be found in the airship chests, but we changed it so that the golem you get a couple example programs in the airship chests, and then after using the golem for a certain amount of time, it would oxidize, and once you scrape the wax off, well, it was twofold, right? Once you scrape the wax off, it would then give you the next program, so you could like see how the next bit worked.
yeah,
Um, and also it sort of nerfed the golems a bit, and that either you'd have to when you were using it, you'd have to keep scraping the wax off
the the
to keep
oxidization,
working.
yeah,
Or yeah, sorry, scrape the oxidization off, or you'd have to wax it with honeycomb, like you do with any other copper thing.
yeah,
So it wouldn't, so you'd have to get honeycomb for that. So yeah, I really like that system, and
yeah,
that was fun to work on. Oh, it also says here, yeah, here's where we used the pipeline, as I called it at the time, because I was interested in CPU design, and that's how, as I said, CPUs work. It has the decode and the execute cycles. First it understands the thing, and then it executes it. Um, so yeah, that saved on lag, but it also halved the speed of instructions being run. So uh, anyway,
yeah,
we've reverted that now. And then finally 0.2.3. This was the last one before the 0.3. All right, so yeah, because the pipeline was quite a big refactor of the interpreter, um, and it introduced quite a lot of bugs. So we basically um, we added this is when we added all the integration tests, where we'd basically have like a little structure where you press the button and it runs a test, and it says what the expected output is and um what the actual output is. So you could test all the functions and see what they do, to make sure that everything's working correctly, which has saved us countless times recently, and I'm really glad we did that. Right,
mm, one of the
super
best
useful.
changes we made.
Yeah, for sure. And then, oh yeah, we added array indexing with negative numbers. All right, we added unit tests using Moxlib,
Right,
um,
yeah, those are broken now.
for expression evaluation,
Yeah,
because a lot of the expression stuff in the interpreter was like subtick and had no outside side effects, so I could basically just run unit tests for that. But whereas like stuff like move and place, you really got to run
mm.
an integration test,
Like you have to
and
see
have
it
the user
interact with
verify it.
Minecraft, and
Yeah,
like yeah, yeah,
and then yeah, we had some bug fixes. So 0.3.0,
yeah.
the next four releases of that we had an alpha, two betas, and then the release itself.
Yeah.
Um,
I think was the first. When did I do the parser rewrite? Because I feel like that was really early in the
the
0.3.
parser rewrite I think was potentially the alpha.
Right.
Um,
Yeah. I think I did the parser rewrite and you implemented functions.
you did the parser rewrite, and then yeah, so 0.3. Let's just talk about the whole idea behind the release. This is by far the biggest release
Mm.
we've done so far, the biggest overhaul of the language, right? It's a complete revamp essentially.
Yeah.
Um, and basically what it does is it turns the instruction based language of, the previous versions into a function based language.
Mm.
And so what I mean by that is, uh, if you've used a programming language before, uh, for example, the print. If you want to print something, you probably call something like the print function, right? And you type that something like with print and then brackets. And what that allows you to do is it allows you to assign the value of calling that print function to a variable. Now, obviously, in most languages, print probably doesn't return anything, or if it does, it returns something not particularly useful. But something like get block in Code of Copper, right, should return the block ID. And before, the way we had to do that is you had to write it to a variable called $block, and then have the user read it from there, which is just
Sucky.
really janky and yeah,
Yeah.
not great. So basically, the idea was to turn everything into functions. So get block would now be a get block function, and it would have different syntax, and the whole thing would be rewritten, basically.
Yeah.
So it was at this point that you basically rewrote the entire parser code from scratch, right?
Yes. I
You
pretty
deleted it
much
all,
got rid of
and
everything. Yeah.
then I started working on adding functions to the existing um, interpreter, and I ran into a whole lot of issues. And so then we later decided uh, um, we would rewrite the interpreter as well and do a better way. But I guess yeah, you wanted to talk a lot
Yeah.
uh the parser rewrite, right?
Yeah.
So go ahead.
Okay. Okay. Right. So as I briefly mentioned before, the parser had a lot of issues with recursions inside of recursions, where basically yeah, it would the a function would call itself over and over again, and then it wouldn't, like when I needed to exit the function, it would still call all of the function, like if there was code that ran after the function, like after the exit, it would run that code like for each time the function was looped. So it would end up running a bunch of code that it shouldn't have because it couldn't exit cleanly. There was like, it basically got stuck. Uh, it got stuck with this like dirty state, um, mainly due to how MC function works, but also just due to the way that I implemented the parser. So it came very apparent to me as we were talking about adding more features like functions and stuff that something needed to change. And I
Hmm.
made the decision to completely rewrite it. So where the last one was a refactor, this was a rewrite. This was like pretty much from the ground up um, rewrite of the parser and
Yeah,
taking,
just using the knowledge you'd gained right from previous iterations to
yeah,
to make it better.
like really all the things I learned from like uh the difficulties I faced with version 1 of the parser. So everything from Codacopper 0.1, all of the bugs. And then also some just code style and practices I got from doing the regex and learning
Hmm.
like that.
Yeah, yeah.
They're very like I feel like I understood stacks better after the regex because it had
Oh
to
yeah, yeah.
handle like all of these stacks. Um
Hmm.
so
Can we
really
just
those
explain
two,
quickly what a stack is for anyone who doesn't know?
yeah. Um yeah, okay. So basically a stack is well,
It's a
it's
data
exactly what it,
structure, right?
yeah, it's a data structure. It's exactly what it sounds like. It's a a stack of things like in an order, right? So from pretty much bottom to top, right? So now there's two operations you can perform on a stack. You can either add to the top of the stack, or you can
Or
remove.
pushing.
Yeah, so you can push, which adds an item to the top, just like adding a block to the top of a tower, like of a pillar in Minecraft. And then you can also remove from the stack, and obviously you can read
Which is called
the
popping.
which is called popping.
Yeah.
So you can push and pop.
And so I like to
Um,
think of it as like a stack of plates where it's a
yeah,
first in, first out system. So when you add something, you're like putting a plate on top, and you can't access the plates below until you've taken the plate on top first. So it's very like you're essentially adding layers, and then you like consume them, and then add them back on, and then you consume them, and it sort of it works well for recursive data structures. It's how variables are stored in recursive functions. Like, so if you have a function in in like something like C, which calls itself, um, under the hood, your computer is storing the variables as a stack, because essentially the most recent variables on the stack are the ones of the most recent function call, and once that's done, it gets popped off, and then you can access the next level as the other function resumes calling, essentially.
yeah,
So it's really useful for recursive stuff, which is exactly what is being used in Code of Copper, right? In the parser and in the interpreter. So
yeah,
yeah, that's what stack is.
yeah. So obviously, version 1 of the parser had to have a stack. There's like not really a way to do it without having a stack. Especially in MC function, because there's no like scoped variables or
Yeah,
anything.
exactly. Because what I was going to say is, in a different programming language, what you'd really do is just implement it as a recursive function,
Mm.
and the compiler would turn that into a stack for you, because, as I said, that's how it works, right?
Yeah,
It's
the
a stack
stacks.
underneath the hood, and you wouldn't need to worry about stacks. You just think about it as higher level. But obviously, an empty function, that's not how it works, and so um,
Yeah,
yeah,
but
a
yeah,
stack is required.
basically, I wasn't that familiar with stacks. Obviously, I knew what they were, but I hadn't used them much because, yeah, high level languages do that for you. And so it was a very naive implementation. So I really wanted to fix these recursion issues. I really wanted to have a version of the parser working with a like actual stack, like fully stack based approach. Um, and so yeah, a rewrite was needed, and a rewrite I did. So I feel like it took me a while. I feel like it took me 2 or 3 weeks to do the
Yeah,
rewrite. Like,
well, 0.3.0 Alpha 1 was, yeah, around about just under 3 weeks after 0.2.3, and I think you'd already rewritten the parser by that point.
right.
Um,
Yeah.
yeah,
And yeah, so it very much changed to have this structure of it was basically this concept of a core loop, right? So it would once it's initialized, there's a single loop in the program. There's no other functions unless they like there's some exceptions now. Some functions like don't have any side effects, so it's safe to like perform them in their own loop. But pretty much as a rule of thumb, there's a single loop to the program, and uh, as it loops around, it checks the type of the thing at the top of the stack, and then branches out based on what that type is. And then the types can have subtypes, they can have different data, and the program knows to branch to this function, then to branch to that function, and then finally perform whatever it needs to do with that piece of data. It can either add now a new thing to the stack, and obviously, like I say, this thing is the next thing to go on the stack, and then when the loop restarts, it then knows, oh yep, okay, so I'm now this thing's going on the stack, and uh this is the new branch, the path it has to go down. So
Hmm.
that was very much the design of that, and it was completely different than the old version, and like I feel like I finally got how the parser should work, and it worked like significantly better. Now that there are still some flaws with it nowadays, like it's obviously not the most refined version. Um,
Hmm.
I would almost say that our current interpreter is version 2 of the parser, pretty much, of like what I learned from the
Yeah,
parser.
because we basically, when we rewrote the interpreter, and we'll get into that in a minute, we took a lot of this same approach. We took a very similar approach as the parser with the with the way we implemented the stack and everything. Uh, and yeah, I think that worked really well for the
Mm,
interpreter as well as the parser.
yeah, yeah, and like, yeah, figuring out how to get the parser working was really cool. Uh, like having it um finally function, obviously, uh,
Hmm.
properly. Yeah, I feel like it was this perfect application of everything I'd learned up to this point, and then, but at the same time, I was still then learning more concepts as I was applying like what I learned, and so that, like at the
Hmm.
end, I was really quite proud of what I managed to do with the parser. Um,
Yeah.
and it worked out really well. And this approach, like basically, I figured out some some like nicety things to go along with this concept of like pushing and popping from the stack, right? I basically came up with um, it would basically at the start of the loop it would store the thing into current to make it easier, like into a data storage called current, to make it easier to compare against. Um, Once again, uh, limitations of uh, Minecraft data packs, but it was a it was a pattern that I came up with in the parser, and as well like setting next. So another data storage called next, and based at the end of the loop, it knew to put next into um, it knew to put next onto the stack, right? Because basically you could get some things where things still need to read from the current state of the stack before it gets to the next state of it. So uh, next essentially happens at the end. Um, yeah, it's a little bit confusing to explain, but yeah, that was a big part I feel in modernizing or making Code of Copper what it is now. Was like that was really the first step, and it also came with improved syntax, of course, because new parser, new syntax.
Yeah, it allowed for us to do multi-character operators finally.
Yep.
Um, so yeah, we added a lot of operators in 0.3.0 actually.
Yeah. Like
We added
all all the
all sorts
assignment
of ones.
operators, so
Yeah,
plus equals, minus equals, etc. Um,
and then we could finally make equality checks be double equals because then we changed the way the variables worked completely as well. We made them scoped and we made them reassignable. You wouldn't be able to do let twice for the same variable anymore. You just have to you'd have to reassign it.
Yeah.
Yeah. So a lot of those concepts from the parser translated into the interpreter as well. So when we rewrote the interpreter, then yeah, we sort of took a lot of those concepts and translated them, right? So yeah, basically, let me explain how the interpreter worked before 0.3.0 and why that limited us and why it made it so darn difficult uh, to implement functions in the interpreter, right? So basically, the interpreter had two parts to it, right? And this is sort of demonstrated well by the pipelines, right? There's the decode or evaluate part, and then there's the execute part. And it had that since the very beginning. I remember the very first feature I worked on in the interpreter is the evaluate function, which essentially takes an expression from the parser and turns it into an expression from the interpreter. So, if it's, for example, if it's just a number, there's no transformation needed there. You literally just, well, yeah, all you got to do is just take the number and essentially feed it through. But if it's like an array, you got to iterate through each of the elements and like construct the array from those. And if it's something like a variable, then you've got to, of course, you have to look it up in the variable table, and yeah, all sorts of things that you got to do, right? And so the way that did is that was implemented as a recursive looping function. So it would do that all in one tick. It would just go through every single, just recursively iterate through it, and find all the things it needed to figure out, and it would figure them out and then return a data structure which was known at runtime. Which worked fine for the initial language because there was no expression types which took more than a single tick to evaluate. Of course, this gets a problem when you want to add custom functions, because a custom function needs to be executed over the course of multiple ticks, right? Because a custom function can call as many other things as possible, as many other things as it wants, and so you can't execute the whole thing in one tick because you could potentially essentially run into an infinite loop. And also, certain things are tick bound, like move, for example. You can't run the move command more than once per tick, otherwise you can just, move an infinite distance in one go, which is not what you want, right?
Yeah.
So that then became a problem because a function can return a value and therefore it's an expression. And so but to work with the thing, it would have to be executed in one tick, which I've just explained why it isn't possible. And so the two things clashed heavily and this worked fine at first because, yeah, we didn't have anything which needed more than one tick. We had two things. We had instructions and expressions. Expressions would be executed or evaluated all in one tick, and then instructions would be executed once per tick. So the decode phase would basically go through all of the arguments to the current instruction, evaluate them, and then the next tick it would run the execute thing. It would run the current instruction, and then it would continue. Right. So I tried to make it work. I tried to implement like a way that it stored state across ticks. So yeah, and I got it mostly working, but it was pretty janky, and uh, yeah, it didn't really turn out well, and there were still some super weird edge cases where if a function was used, if two functions were like added together, it would work fine. But if you added two functions plus one, like if you call two functions, add them together, and then add one to that, it would just produce some weird result. And we just decided, yeah, okay, we're just gonna rewrite the whole thing then. So yeah, we did. So the interpreter now uses a pretty similar system to the the parser. So basically, there's an internal stack which contains everything that the interpreter is currently evaluating. There's no difference between evaluate and execute anymore. There's just evaluate. And it basically goes through the stack in a loop, and it says, okay, what's the next thing on the stack? Okay, evaluate that. And so if it's something like a number, it will just literally pass that through the system because numbers are the same in the parser and the interpreter. They're just a literal number. But again, if it's a variable, it will look it up in the table, and if it's a function call, then essentially what it does is it pushes a block containing the contents of the function onto the stack, and then that block will then get executed command by command because it's on top of the stack. And then a block will just essentially push one instruction at a time onto the stack, which then each get executed sequentially, and each thing just pushes the things it needs to on the stack, and then because the stack exists, it it can essentially, that stores all the internal state, and then it can wait as long as it wants for the next thing to be executed. So yeah, that is essentially how it works. It's a little tricky to explain. I find it helps with a visualization or like looking through the code. But yeah, basically the initial interpreter code was written like you might write it in another programming language. And obviously that doesn't work because this is MC function and it's different to everything. So yeah, but now it works really well. And yeah, the functions work flawlessly. There's no problem with waiting across ticks. The function can take as long as it wants. It can recursively call anything it wants. And yeah, it works really well. I think that covers most of 0.3.
Yeah. Yeah, so we like it went from, yeah, it's now pretty much a functional language. Like
Yeah,
I mean, it's got side effects
there
and
are still
functions.
some like instructions or statements. Those are essentially let. We also added const and var. So const is for constants, cannot be overwritten at any point, and then var is global variables, which we said we were going to change, but we never did.
Yeah.
And we chose var because JavaScript var are global variables.
Yeah. Yeah. So
But yeah. And then we added tons of operators. We added booleans. We added scoping for variables so that it wouldn't be global variables that created within a function stay within a function, because otherwise you
yep.
can't really do recursion unless you use a stack.
Yippee.
Yeah. And then objects. When did we add objects? I feel like we added objects before.
I feel like they're in 0.2 at some point.
Oh yeah. Yeah, objects were 0.2. I just missed that. But then yeah, we added dot notation for objects. Um, and yeah, so 0.3 was a massive overhaul. The whole thing changed. Um, got rid of dollar inventory and dollar pos, uh, because yeah, we didn't need them anymore. We just had functions for getting the inventory in position. And yeah, the whole language is just like super, super nice to use now.
Mm.
Um, yeah, and then there's just been 3 more releases since then.
And only really one of them counts because the other two have just
Two of
been
them have
version
just been
updates.
updating to 1.20.5 and 1.21 respectively. Yeah, 0.3.1 was quite a big one as well. Because that was, as we called it, the big split. Um, so yeah, let's talk about the big split, I guess. So up until this point, Code of Copper was, a data pack which allowed you to write in the Golem script programming language to control these copper golems that we made. One thing that had been, I'm not sure if people have been requesting it or if it was just an idea that we'd had from the beginning, is to sort of allow you to, or like create a version of the language which was separate from the golems and allowed you to sort of manipulate the world in like a less survival friendly way. And sort of have more control over what the command's doing and not having it limited by the items uh, that the golem has, right?
Mm.
And so in 0.3.1 we finally did that. We separated the golem script language into its own data pack called golem script, which is essentially just a library for which is used in Code of Copper. So the golem script language, the parser is now all in golem script. The interpreter is now all in golem script, and most of the standard library functions are also in golem script. All the
Yeah.
standard library functions except for the ones which actually use or modify the golem itself. So move, place, get block, pause, all of those things are still Code of Copper specific. But all the parts of the interpreter and all of the new standard library functions which we added, which was a big improvement as well. We added a lot of new functions to help the programmer do things
Yeah.
in the language. And yeah, so we split that up, and that took a little while to get working. But the cool thing is twofold now. So well, yeah, Golem script is now a library, so you can theoretically, if you want, make. We created a nice API for it, so you can, if you want, make your own data pack which uses the Golem script library and implements a runtime for Golem script. And basically, a runtime is just the context in which a program runs. And yeah, so Code of Copper is one of the runtimes, but you can really do whatever you want with it. And also, we added the ability to extend the standard library functions and create your own ones using the API. And yeah, so Code of Copper basically uses that to add its own functions like move and place. And yeah, and then Golem script is a separate thing now. And yeah, that's pretty much the
Oh, and we added procs.
oh yeah, that's one of the procs. Yeah. So yeah, Golem script is basically a fully fledged language at this point. It has the ability to do a bunch of things, including regular expression matching, which
Yeah.
is kind of funny honestly.
I'd say it
For a
has a
Minecraft
standard library
language,
that rivals some regular programming languages.
yeah,
Um,
it's got a pretty good standard library now. It's it's got 40 odd functions built into it. Uh, and yeah, I think it's in a pretty good working state at this point, honestly. Um, but I guess before we go, because this has been a long one, but before we go, let's talk about the future of this data pack, I think,
yeah,
and where it's heading now. So we haven't touched it in several months because, well, apart from updating it to the latest Minecraft version, we haven't touched it in several months. Because we decided after 0.3.1 we were going to take a break from Code of Copper, and we were going to work on other projects. Um, so such as Zoglin, although that was later, and other secret projects which uh, we haven't shared yet.
well, let's just say
Um,
the future of Golem script might not just be in a data pack. I'll give that as
okay,
a.
well, no, we can talk about that. We can talk about that.
All right, yes, yes.
So, uh, yeah, so Golem script, uh, one thing that's sort of annoying about Golem script is the limitations, not of Minecraft itself, but of the input system, because Golem script requires you to write code in books in Minecraft, and for obvious reason that's annoying. They don't use a monospace font like code editors do. They don't have any syntax highlighting. The pages are tiny, so you gotta like split up your code over multiple pages. There's
Yeah.
so many really annoying things about writing it in a book.
Mm.
And so what we were thinking is, what if we had a version separate from Minecraft where you could essentially test out your programs and run stuff, uh, in a much better development environment, and then, copy it over into a Minecraft book later. So we are working, although we haven't actually touched it in a while because we've been stuck on other projects, but we've been working on a Golem script interpreter in Rust, um, which essentially allows you to write Golem script in whatever text editor you want, and run it outside of Minecraft, test it first, and then bring it in. Obviously, you can't test stuff like move and place because that inherently requires a Minecraft world, but a lot of the stuff you can do. Um, so yeah, that will be cool once that's done. Um, one thing which we've been wanting to add for ages is floating point numbers, because currently the only numbers we have is integers, and obviously there's only a certain amount of things you can do with integers.
Yeah.
Um, so we want to add that in the future. I'd say probably if when we come back to Code of Copper, that's probably the first thing we'll add. There's sort of two main things I feel like. Oh, and at some point we want to add like a module system where you can like import code from other places. So we might work on that. And also another thing we mentioned is improving the error messages, just like improving the experience, maybe adding more customizability to the API. I don't know if we will ever be able to inject functionality into the parser, but you know, never say never. Uh,
Dynamic parser would be very cool.
yeah,
Um, I don't know
but
how possible that is, but
yeah, the parser is different to the interpreter, and it's much less dynamic and stuff. But
yeah.
maybe
I mean,
maybe one day.
like that was one of the like the big things about the big split. Obviously, we're talking about you can make your own runtime, but we really focused on making the interpreter very extensible. So like we've
Yeah,
implemented all these callback functions. There's like a whole API not just for like running programs, but for adding custom
adding, yeah,
functions and like
yeah.
stuff like that. Um,
Theoretically, uh, if you wanted to, you could write your own parser and just feed the output of that into the interpreter as long as you use the same AST format.
yeah,
But that's limited. You can't add your own custom literals and stuff.
yeah,
But you could, for example, change the syntax. You could make Golem script the same semantics but a different syntax if you really wanted to. And yeah, so yeah, it's pretty cool to play around with the Golem script library. Anyway, I'm excited for the future of this. I'm not sure we'll make a whole lot of changes because we really want to focus on other projects that we've worked on. Um, but yeah, I think it was definitely fun to do all the features we've done. It's fun to do stuff. We'll probably do something, make a new runtime at some point for certain things.
yeah.
But yeah,
Something
um,
I've been like cooking up in my mind somewhat is creating a version of Golem script for like map makers, for like people that want to be able to write custom events into their creative worlds or maps or whatever and not have to like write MC function.
yeah,
Um
like Golem script for map makers. Yeah, yeah.
and I feel like that could be really, really cool. Like even though it's obviously Golem script is not very performant, just due to how it works, it's unfortunately not.
Oh, yeah, one other thing is I do want to try and experiment with a certain way of improving the performance potentially of Golem script. I might write a little mock language, and see if I can get the performance to increase, and then if it does, then we can try and rewrite Golem script at some point. Maybe
Ooh, that
we'll
would be
see.
cool.
Yeah. Okay. I think that's a good place to end it.
Yep.
Uh,
All right.
and yeah, I guess we'll see you in the next episode.
This has to be done. Stupid, stupid villager.